everyone, I'm Muskan from Sri Venkateswara College of Engineering, currently pursuing my bachelor's in Computer Science and Engineering in Cybersecurity. Today I'll be presenting few topics from digital design and computer organization. So the first topic is NAND and NOR implementation. Any logic function can be implemented using NAND gates. To achieve this, first the logic function has to be written in sum of products SOP form. Once logic function is converted to SOP, then it is very easy to implement using NAND gate. In other words, any logic circuit with AND gates in first level and OR gates in second level can be converted into a NAND gate circuit. Consider the following SOP expression. F is equals to WXY plus XYZ plus YZW. The above expression can be implemented with 3 AND gates at first stage and 1 OR gate in second stage as shown in this figure. So these AND gates will give us the output of WXY and XYZ and YZX, which will be the inputs for the OR gates, which will give us the function WXY plus YXZ and YZW. If the bubbles are introduced at AND gates output and the OR gates inputs, the same for NOR gate, the above circuit will become as shown in this figure. Now replace the OR gate with a NAND gate. Now we have a circuit which is fully implemented with just NAND gates. Realization of logic gates using NAND gates. So here we have the inverter. In this NAND gate, we give X as the input and we'll get X bar as the output. Implementing AND gate using NAND gates. In this NAND gate, we give X and Y as the input. So we'll get XY bar, which will be the input for this NAND gate, which will ultimately give us F is equals to XY. Implementing OR using NAND gates. In this NAND gate, we give X as the input value, which will give us X bar. And here in this NAND gate, we give Y as the input value, which will give here us Y bar. So your X bar and Y bar will be the input value for this NAND gate, which will give us the function as F is equals to X plus Y. Realization of logic functions using NOR gates. Any logic function can be implemented using NOR gates. To achieve this, first the logic function has to be written in the product of sum forms. Once it is converted to POS, then it is very easy to implement using NOR gates. So here we are using the NOR gate. The inputs is X and X, which will give us the output of X bar. Implementing AND using NOR gates. In this NOR gate, we give X as the input values. Here we'll get X bar. And in this NOR gate, we'll give Y as the input values. And here we are going to get Y bar. For this NOR gate, here we have X bar and here we'll have Y bar. And after solving it, we'll finally get X into Y. Implementing OR using NOR gates. So in this NOR gate, we give the values X and Y as the input values. And as the output, we'll get X plus Y. Implementing NAND using NOR gates. In this NOR gate, we'll give X as the input value, which will give us X bar. And in this NOR gate, we're going to get Y bar, which will be the input values for this NOR gate, which will ultimately give us X into Y, the whole bar. My second topic is Verilog model of a simple circuit. So Verilog module of a circuit encapsulates a description of its functionality as a structural or behavioral view of its input-output relationship. A structural view could be as simple as the netlist of gates or as complex as the high-level architectural partition of the circuit into major functional blocks such as arithmetic and logic unit. So here we have a simple Verilog program. So in this program, we are using V, W, X, Y, Z, and F. So first we write all the variables here. And then we say which are the inputs and which are the outputs. So in inputs, we have V, W, X, Y, Z, and F as the output. And in var, we have W1, W2, and W3. So first, we take the NOT gate G1. So here we are passing Z, which will give us the output as Z1. So here we give W1 as the output and Z, which is going to be passed. And next, G2 is the AND gate. Here we give the output as W2 and the inputs are W1 and Y. And G3, we have W3 as the output and V, W, and X as the inputs. And at last, we have an OR gate here. F is the output and W2 and W3 are the inputs, as you can see here. So what happens in this program is it will calculate G1 as Z bar. So it means W1 will be calculated as Z bar. So here G2 will be having the inputs as Z bar and Y, which will give us the output as Y into Z bar. Here in G3, we have V, W, and X as the inputs, which will give us the output as VWX. So W3 is VWX and W2 is YZ bar. So at last, when we are implementing the OR gate in G4, so the function will result as WXYZ plus Y into Z bar. Thank you for watching.